Assalamualaikum warahmatullahi wabarakatuh. My name is Hafiz bin Muhammad Anafin and my mention number is 2078661. So I'm here is to present our lab experiment, which is Dsb-Sc and Dsb modulation and demodulation. So first of all, I'm going to state our objective in this lab experiment, which is the first one is to implement the Dsb-Sc and SSB modulator. Our second objective is also to implement the Dsb-Sc and SSB, but the demodulation. So I'm going to describe what is this Dsb-Sc and SSB. So Dsb is stand for double sideband suppressed carrier. It was a method of transmitting amplitude modulated wave. So in this scheme, only the sideband of modulated signal are sent, while the carrier signal is deliberately removed or suppressed. So next is SSB, which also referred as SSB-Sc, which is single sideband suppressed carrier. So SSB is an amplitude modulated technique where only one sideband is transmitted over the communication channel. So next we're going to simulation part, which is simulation of our lab experiment. So by using the MATLAB, this is our block diagram. We can see that we have message signal and also carrier signal. So for the result, we can see that our message signal, which is we use 2 volt and 10 Hz, and the result, we can see the result. And also next, we have carrier signal, which also 2 volt, but with the 1000 Hz. So since this signal is double sideband, we can see that they have 2 sideband component, which are WC plus WN, and the second component is WC minus WM. So after the simulation, we do it in the lab. So this is the result of the experiment in the lab. However, first of all, we're going to see the Dsb-Sc modulation. So in this modulation experiment, an audio signal is generated as 300 megavolt sine wave with the frequency 1 kHz. So the audio signal is applied to the audio input of the modulation system. Simultaneously, a carrier signal is generated as 300 meter volt sine wave frequency of 100 kHz. So this carrier signal is applied to the carrier input of the modulation system. So by combining the audio signal with the carrier signal through the modulation process, the resulting output signal will contain modulated information with the carrier service as the carrier wave for the modulation. So for the overview, we can say that modulation is the process of encoding information onto a carrier signal for transmission. So it allows us to send signal over long distance through the various media. So this technique varies depending on the specific requirement of the communication system. So For the experiment 1, this is the result for our experiment. So the yellow one is TP1 and the green one is TP2. And for the TP3 and TP4, the yellow one is TP3 and the green one is TP4. For the TP5 and TP6 is also the same. The yellow one is TP5 and the green one is TP6. And we also can see the SSB signal. So for the Dsb signal, the carrier signal is eliminated, or we can say not transmitted at all because of the suppression. So efficiency utilization of bandwidth is achieved by transmitting only the sideband without the carrier signal. So the power in the modulated signal is evenly distributed between the upper and lower sideband. So this is because to ensure a balanced representation of the signal. So next is for the demodulator. Also, we use the SCT, SITS, Dsb-Sc, and SSB demodulator for this experiment, which is demodulator experiment. So in the demodulator part of the setup, and audio signal consisting 1 volt sine wave with the frequency 1 kHz is applied. Additionally, 1 volt sine wave with a frequency 200 kHz is also applied to the carrier input. So the output signal from the SCT5, which represent the demodulator signal, is then connected to the signal in the input SCT6. So by connecting the output of SCT5, which is from the experiment before, to the signal input of SCT6, and using the same carrier signal, this configuration allows for the processing or analyzing of the demodulated signal in SATC. So this is the result for our demodulation. Same as the modulation, TP1 is the yellow one and TP2 is the green one. For the TP3 or 3 and TP4, representative yellow and green also. For TP5 and TP6, the TP5 one is yellow and the TP6 one is green. So for the demodulation, we can say that by adjusting VR1 and VR2, we can achieve the maximum amplitude of the demodulated waveform without distortion, and fine-tuning this variable allow for optimal control over the demodulation process. So it will ensure that demodulated signal inhibit the highest possible amplitude while maintaining fidelity and avoiding any undesirable distortion. So for the conclusion, you can say that phase adjustment, amplitude adjustment, and modulation index are critical factors in obtaining a modulated signal. So this adjustment allows for precise control over the modulation progress, ensuring the desired characteristic of the signal. So Dsb-Sc modulation provide an efficient utilization of bandwidth, resulting in the minimized power consumption. So by transmitting only the sideband and suppressing the carrier, Dsb modulation optimizes the use of available frequency resource. So in the demodulation, the goal is to successfully restore the original signal from the modulation. So when demodulation, signal accurately resembles the original modulated signal. The demodulation process is considered success. This ensures that demodulated signal it contain the same information as the original signal without significant distortion or loss. So I think that's all for me. Thank you for hearing.